Hello everyone and welcome back. So in this video we're going to be taking a look at sampling and scaling across patches. Now Lee, what do you mean when you say that?
Well, if you jump back into Unity real quick and start up the application so we can look at it, what we've got from the last video is we're getting height data, but every single patch, if you jump over to the scene
Yep,
view, it might make it a little bit easier,
it
but
will.
every single patch shows the exact same terrain data. Now, the reason why this is happening is the way that we're building our terrain grid now. Each terrain grid is got its own pivot, which is at the center of that terrain, and each vertice or vertex is referenced based off of that position. So the vertex itself doesn't know to offset based on the pivot of the terrain patch itself. So what we need to do is to go ahead and tell our sampling request for height data to take that into consideration so that we're not repeating the same sample data. We'll be pulling the information for that specific terrain patch
For
itself.
anyone that may be confused about this back over here in Photoshop, can you explain here on this map?
Right. Let me zoom in. Say right about here because this is about where we're picking the information. What's happening is each vertex is asking based off of its local terrain patch pivot saying, I need +1 or a point, say +1 +1 or -5 -5 over here. But every patch is asking for that same piece of information. So every patch vertex that's at 0.11 is asking for that same piece of information.
And that's
Every
with you starting here at about the center of the map, right?
right,
Because you've
if
centered it up.
right, because this is centered, so about the midway of this map crosses right at about this point where my mouse cursor is now.
Okay.
So right about here is where it centers up. So every vertex in the patch is referenced based off of that center point. Now what we need to do is go, okay, well, the very first terrain patch, this information is correct. But let's say the terrain patch that's just to the right over here, each point should be pulling information sampled off of the information over here.
Right.
And the patch to the right should be doing the same and such and such.
Very
And,
nice.
and that's what we need to do. Luckily, we've already got that information inside of our terrain patch class. We just have to tell it to use it.
Okay.
So what we'll do is we'll jump over to Unity just to make sure it's still not running, and then
Yeah.
into code. Now we'll go into terrain patch, and we are using the create grid method to get the information. The information that we're at, or where we're making that request, is this line right here. Now we're taking in our vertex X and Y, we're multiplying it by spacing, and then we're offsetting it or correcting for our offset to make sure that the vertexes or vertices are arranged around the pivot point of our patch. But we're not taking into consideration where that patch lies in real space. So we have a property that we created before called position that does have that information that we need. So all we need to do is add that to our equation. So we just tell it to offset the x by our positions dot x and offset the z or z by its positions dot z or z. I've been talking with Gavin too much. And then we need to do the same thing down here.
Okay.
So if we build that, and if you jump over and run it, give it a sec to
And
build. Now everything is different. Now, this brings up a really, really cool thing. Do you know what that is?
well, first thing, I'm not seeing giant gaps between these patches.
Very good. We get seaming for free. And the reason why we get seaming for free is the way our vertices are lined up. Each edge has a vertex at the same point in space as its neighboring patch.
Right.
So the way the sampling algorithms work, it's pulling and sampling that information at the same point. So as long as we make sure that all of our calculations that we use are consistent from patch to patch, the seams of our patches will always line up. So
Gotcha.
it's a free operation. It's nothing that we need to do any extra calculations for.
Very sweet. All right,
So,
so
but it does kind of bring up another issue. If you look at the terrain,
okay.
it's kind of jagged and it doesn't look very realistic.
Right.
So we need to have the ability to scale our terrain.
Okay.
So let's go ahead and do that. What we want to be able to do is have a way that we can assign a scale factor. So we can take our base map and either make it smaller or larger for sampling purposes. Easiest way is to go ahead and put this in and visually show it. So if I go into our terrain generator, I'm going to hard code this for now. We'll actually change this up later. But I'm going to make a value, call it scale, and I'll give it a value. I believe we're using 17 now for our patches.
At one point, yep, still are. Okay.
Okay, so we're using 17, which means our patches are going to be 16 across space-wise. And we're using a spacing of 1, and we're using 3 patches in our generation. So let's see, can I bring up the calculator?
I got it. Ah,
Sorry,
it's all good.
I had already typed it.
Here you go.
Okay, cool. All right, so if we know we've got 16 units across and we've got 3 patches that make up a 3 by 3 grid, we're representing 48, we're going to have 48 spaces across. If I do that by, clear our vertices, where we have 49 per, but we still are overlapping 2 of those.
Mm-hmm.
So, and I'm just doing this hard real quick. So if I do 17 times 3 gives us 51 and minus 2. The cover the 2 overlap, well, 2, so 1, 2, yeah, 2 overlapping, so 49 across. So if I take 49 and we've got a map that's 2048, 2040. I could use my numpad, couldn't I? Divided by 49 means I need to divide our map roughly by 41.8. So what I'll do is take our scale and I'll take that at, what did I say it was? 41.8?
41.8.
Okay, so 41.8 short-term memory damage. So from here, we can take our X, going to divide it by our scale. So, no, I need to multiply it by scale. Because what I'm doing is I'm making our X stretch out over a larger scale part of the map. So I'm thinking about it differently. And I'm going to do the same thing with Z or Z. And I need to put these in brackets just to make the integers happy. So this is not going to work out perfectly numerically, but it'll be close enough. So we go ahead and build that. Go ahead and run that.
Sure.
So what we should see is our entire 2K texture trying to map out across the entire map. Now our height's going to be a little bit high,
Mm-hmm.
for it, and our resolution is low.
Mm-hmm.
But you can see, if I can take the mouse, that here's the ocean, the flat areas around it. This is supposed to be the representation of what it was trying to do. If I bring this one up, this might help.
Hang on one second. Let me do this.
Yeah, can you do that for me?
Well, actually, I was instead of resizing it, I was just going to grab this,
Okay. Oh, move it
size it
up.
like such. As long as we don't click on Unity, that should be very nice right there.
Okay. So what we're doing is we're trying to force this representation. So this is trying to be, if I remember geography correctly, Ireland, and this part over here would be Britain and Scotland up here. And it's trying to force it, but our resolution is so low that we're not getting, a perfect representation. And our height is a little bit off on it. But we can start to see that, Scotland's got higher areas than um, Great Britain does, and Ireland's kind of in the middle. So now we can have some fun with this. So
Okay.
if we go ahead and pause this, and let's go ahead and jump back over into code. I'm trying to slide, a little bit of lag here. Let's take our train patch. Then we're going to bump this up to 49. And take our height, strap this down to 5. Actually, let's try 2.5. No, I made it an integer. Can't do that. So let's go with 3. And go to generator. Now I need to recalculate. So now I've got 49 times 3 minus 2, so 145.
145.
Yeah, 147 minus 2.
Oh, minus 2. Okay.
So divide that by 145. So we'll change our scaling to 14.1. Go ahead and build that out if you want to give that a run. This is a higher resolution map. We're still using 3 terrain patches with a lower height. Now if we zoom out,
That's
hold
just
on, I'm going to change up the texture.
okay. Go ahead.
Our UV part of it has done everything it can possibly for us. So let's go ahead and rebuild it without our UV. So as you pick up the resolution in the map, we can start to see that we're getting closer and closer to what we're expecting it to see.
Mm-hmm.
So now this is a very small representation of the UK.
Right.
So probably not going to take us very long to run across this.
So what about these seams that we're seeing in here right now? If let's go ahead and just jump in here real quick. I'm just trying to picture what somebody would be asking.
Oh, I didn't even see the seams. The seams are coming up.
Like here. Because now we're definitely seeing two different things where this point and the
Right.
point under here. Is this just going to be because of the accuracy that we're dealing with at the moment with the 14.1?
Because we're getting rounding errors. Remember I said our algorithm has to be very specific, so we're not getting any rounding.
Mm-hmm.
So these points come up close enough. That's probably where that's coming in from.
Okay.
So because it's going, oh, well, this point isn't exactly that point, so we're getting some difference over there. Are we getting it over on this side too? Yeah,
Oh yeah.
we are. So once we get the real method in,
Mm-hmm.
those should go away.
Okay. Just wanted to kind of bring that up because
Yeah,
again,
I couldn't even see it until you zoomed in.
oh wow, figured a student watching this might be curious.
Right. Well, they can probably see it. I'm looking at it using 4 colors, I think is what my display shows.
Oh, I gotcha. Yeah,
So I see like a light gray, a greenish gray, a darker gray, and some white.
gotcha. All right, well, that puts us at about 15 minutes. Is that good for this video here?
Yes.
Okay, awesome. Well, that will wrap this one up. Thanks a lot.